Welcome to Onshape for Makers, where we are creating models to go to the shop. Tonight is a little different than normal. We're going to talk about variable-driven geometry. We're going to make a slipcase, which you can put your glasses in, you can put your toothbrush in, whatever. Most of the stuff I have seen, they use a soap dish, but I'm tired of soap dishes, so we'll go with this. We'll use a variable for the X dimension, a variable for the Y dimension, a variable for the Z dimension, a different Z variable for this dimension, and then we will have a dimension for the overlap. When we put the two together, we will dimension the wall thickness, and we will calculate, using some of the variables, the radius, so we don't get a zero corner if the wall gets too thick. We're going to just work along and talk about several things and the order to do things in and why we're doing them in that order as we go. So we'll start with a fresh Part Studio. We will go up to Workspaces. We will select the hamburger menu. We'll pick millimeters. We'll pick grams. That should get us going. We're going to do very different. We're going over to the right hand side and pick variable table, and we're going to fill in variable names. We're going to put an X dimension in, a Y dimension in, a Z for the body, a Z for the cap. We need the slip joint overlap value. We're going to need the wall thickness, and we're going to need the corner radius, and the thickness of the wall where they go together. That's just slightly less than half of the overall wall thickness, so it will slide instead of bind. The starting dimension, just for the fun of it, we'll start out with 42 and 32. And the body, we can make it, 70. And the cap, we can make, 30. Overlap, we can overlap at about 20 millimeters. Use a wall thickness of 3 millimeters. Use a corner radius is going to have to be no less than the wall thickness. And to get that number, if you want to use a variable, you start with a pound sign, and it will list all the available variables. So we're going to take that and say the wall thickness plus 2 millimeters is as small as you can have for a corner radius. The slip wall, which would be half the thickness of the regular wall, would be, again, a pound sign, and we'll go down to wall thickness and type in /2, and then we're going to subtract 0.2 millimeters to make it slightly undersized, because when we print it, it will be slightly oversized due to the way printers work. So these variables should get us started in building our model. I'm going to set them up that way so we can look at them and we can see them. There's a whole bunch of them over here that we don't need because we've got them over there, and just makes a mess. So I'm going to highlight the first one, hold the Shift key, highlight the last one, right click and say Add Folder. Call it Local Variables, fold them up in a folder. If I want them, I can go to the arrow and get them back, but they're all over here, so I don't really need them. So let's go start on the top with a sketch. We'll go in for normal, and we will draw a rectangle about the shape of the slip tube. So go to G for generalized rectangle. It starts in a corner and just go out anywhere. It doesn't matter. Click. And auto dimension will go down to what would be the X value. We type in, this is an oddity with Onshape. It's just the way it works. You have to type a number before you can type the pound sign. So you type a number, you backspace, and then you type the pound sign and the X dimension and enter twice. I can't tell you how confused I got the first time I tried to do the pound sign, and other things happened. So 1, backspace, pound, Y dimension, enter, enter. And I'm going to escape and move these out of the way so it looks better. And that is the basic shape of the slipcase. I'm going to go up here to the fillet tool, and this is fillet under sketch, not fillet as a feature. Those are different. Well, we'll talk about that in a minute. And I'm going to pick the 4 points to get the corners, and the reason I'm going to do this is, you'll see in just a minute, it's got to do with propagation. But we're going to hit the enter key, and it's going to ask for the dimension. We can type in pound sign, and pick corner radius, and enter. And now this corner radius is driven by this table. If you look at it, you can come over to this table, and we'll take this 32 number here, and we'll type in 22. And if you watch the sketch will move because the sketch is live tied to this table. We'll go back to 32. So these are driving this in real time. This is half of the part. We need to make a second half of the part, and we could sketch it and go through it, or we can simply mirror the part. And the easy way is go to the line tool and then construction, and simply draw a vertical line of any given length and hit the enter key, and then do a dimension and dimension it at some distance. It doesn't matter. I'm going to put 10 in because 10's a real good number. And we're ready to go. Now we can mirror this part across this line over to here. And I will show you why that's important. We'll go to the mirror tool, pick the fold line that we drew, and then box select, and you have a mirrored copy of this. Escape to get out of mirror, and it looks whatever, but if you come back to this and you type in 22, you'll notice they both moved. That's because this is a mirror of that. I only have to build one of these. This one will follow it. And the great part of that is, being as how these have to be mating parts, they will always be the same size because they're mirrored in the definition of the parametric elements. So anytime I change half of the slip tube, the other half will always change with it. That's part of the wonderment of parametric modeling. So we're going to go, and the reason we did these corner radius and this one is when we mirror it, they're already over here and I don't have to do them again. Check mark on the green, tilt it up a little bit, and I'm going to go up here to new solid on extrude. I'm going to select one of them, go up, type in $Z body, and hit the enter key twice, 3 times. And there is the body for the Z. I will re-enable the sketch, which automatically gets disabled the first time you use it. Unlike some other systems, the sketch is not consumed by use. You can go back and continue using the sketch time after time. It's not that way in all systems, but it certainly is in this system. So we're going back to extrude, new solid, and this time we're going to do $Z cap. And we have our two parts. To make it look better, I'm just going to highlight these two parts, right click, select Edit Appearance, pick something that looks decent and put it up there because I don't like that blue. I'm going to do P as in planes to make them go away because I'm tired of looking at them. And now what we need to do is we need to put a radius on the bottom of these two parts, or the ends, if you will, of those two parts. So we will get the fillet tool, and this is the fillet tool out of the features list, not fillet tool out of sketch. I know that is really confusing. Sketch, believe it or not, is a feature just like all these other features, and one of the tools inside the sketch feature is called fillet. But there is also, besides sketch, there's extrude and rotate and everything else, and one of them is fillet and one of them is chamfer. So we're going to use this feature, and we're going to select the bottom, and it will propagate up because that's how we have it set. And we're going to do a dollar corner radius, and the dollar corner radius will force the bottom radius, or the radius on the ends of the tube, to match the radius on the sides of the tube. And there we go. Now we have tubes. What we need to do is hollow the tubes, and the easy way to hollow the tubes is to use another feature called shell. And we will go to shell, and it will say what is the shell thickness, and we're going to once again say £, and we're going to wall thickness and hit enter. And then we're going to select faces to remove, and we want to remove this face, and we want to remove that face, and check mark. To show you what they look like, I'm going to go onto this face, right click, and say section view, and then tilt it down and catch this little arrow and push it back, and it will make a section view. Green check mark up here. It will make a section view, and you can see how we did the shell and how the shell calculated the wall by calculating off of this fillet here and offsetting a fillet of equal size. Well, anyway, back over here under features, by the way, this is just a list of steps that Onshape provides, and they're editable steps. I can move shell up and do shell before fillet. When I do that, the shell is going to be working off of, let me turn the fillet off, because and when we get down to where the shell runs, the tube is still square, so the inside corner will be square. Then when I apply the fillet, by unsuppressing it, you'll see how this edge distance gets real thin in here. So the order was important, so if you grab the fillet and push it above shell, now it forms, let me suppress that, now it forms this radius, and then when we re-enable shell and it executes, you'll see that it now has a radius and it has a constant wall thickness. By the way, when Onshape stores your model, it doesn't store all of this stuff. It just stores these instructions for build. When you open it up, it runs the instructions. It's an amazing thing, but you can come in here and you can temporarily disable any feature simply by right-clicking on it and say suppress, and what that does, it suppresses the execution of that step when Onshape reads through the feature list to build the model. When you turn it back on, away you go. We now have a hollow. I'm going to right-click over here and say turn off view, and I need to make a sketch. And the sketch is going to be on the very top lip of this part. So I'm going to say sketch, N for normal. I'm going to go to use or project. I'm going to select all the edge lines. And yeah, there's other ways to do it, but this is too much for tonight. And to double check it, I can go to part 1, hide my part, and I should see a full periphery. If I have a good sketch, I can finish up sketch with a green check mark, and now I'm going to go to extrude, and I'm going to cut the step in the side of the part. Before I do, I'm going to turn section view. Where'd section view go? Oh, that's running. I can't get to section view. I can get to section view now. You can't get to section view when you're in the middle of a feature. So I'm going to push this in just ever so slightly until we get past the corners, and green check mark and leave it. And now I'm going up to extrude, and I'm going to do what they call a thin extrude, and I'm going to do a remove, and the amount I'm going to remove is going to be £, slip wall thickness, okay? And I'm going to go to the depth. The depth I want is the slip overlap depth. And what I want to use is sketch 2. And I need to bring it the other way. And you can see where it's coming. Pull this slider. This slider, by the way, is interesting in itself, but you can see where it has cut the side down, and if I hit green check mark, I now have half of the slip joint. To get the other half of the slip joint, I'm going to go and turn off section view. I'm going to click on top of the part, start a new sketch, go normal to the sketch, and this time I'm going to take the inside instead of the outside. And I'm going to just like this and take the inside. All the way around. To double check it, I'll go to part 2 and hide part 2 and make sure I have a continuous path. Turn part 2 back on, tip it back up, green check mark. So we want to go to extrude, thin, remove. We're going to do £, slip wall thickness, and a tab. We're going to go to £, slip overlap, and a tab, and then we will select 3 for sketch 3, for that's what we're using for a boundary, and we should see our inset. If we click green, we have a finished part. If we zoom back in, you will see everything is perfect. Now the way we test it is we come to slip overlap, and from 20 we'll make it 10, and you'll see this jumped up, this got shorter, so that worked. We'll go from 42 to 33, and that worked. We'll go from 32 to 25. And that worked. What else are we missing? We'll go from 70 to 66 or something. I don't know. Not much shorter. We'll go from Z-cap of 30 to Z-cap of 25. And that worked. And everything appears to be working, except we didn't try the wall thickness. Let's try a little thinner wall. Let's go to a 2mm wall, and everything works. So briefly, that's how it works. If you start off with the sketch and you mirror it, then these two are locked together, and they always have to follow. By driving them with a variable table, you can force them to play together so the two parts always fit together. And by watching your order, you can get a nice clean bottom by doing the outside radius before you do the shell. That's about it for tonight. It ran way too long. Have fun. Talk to you later.